So think about how you unlock your phone. You probably use your face or your fingerprint dozens of times a day, right? But what if that's just the very beginning? Today, we're going to look at the future of biometric security. And trust me, it goes way, way deeper than what's in our pockets. I mean, we all trust our faces and fingerprints to keep our most personal stuff safe. But what if the really secure keys aren't the ones we can see, but the ones hidden just underneath our skin? And that's exactly what we're going to get into in this explainer. We're exploring those hidden keys. We're going to look at the incredible new ways our own bodies can be used for identification, turning parts of ourselves we barely ever think about into some seriously powerful digital security. Look, we all get it. Face and fingerprint scans are everywhere. They're super convenient, they're fast, but honestly, that is just the tip of the iceberg. The human body is this absolute treasure trove of unique data, and researchers are finding some really ingenious ways to read it. Okay, so let's get into the really cool stuff. We're about to do a quick tour of what's next in biometrics. And yeah, some of this might sound like it's straight out of science fiction, but I promise you, these are all very real fields of research. First up, the way you walk. It's called gait recognition, and it analyzes the specific rhythm and pattern of your stride. Now, the brilliant part about this is that it's totally passive. A system can identify someone from a distance just using regular security camera footage, and that person would never even know it happened. Next, something you literally can't see with the naked eye, a facial thermogram. An infrared camera can see the unique heat pattern that's created by the blood vessels just under your skin. This heat signature is totally yours. And get this, it even works in complete darkness. And sticking with that infrared idea, we've got finger vein recognition. If you shine a near-infrared light right through your finger, a sensor can actually capture the unique web-like pattern of your veins. And because it's an internal feature, it is incredibly difficult to fake or copy. Now this one's wild. Researchers have found that the skin directly under your fingernail, your nail bed, has this unique parallel structure. And special optical sensors can actually read that pattern right through the nail, creating this one-dimensional map. It's almost like your own personal barcode. Okay, so now we're moving from your physical structure to your body's own electrical signals. An ECG, an electrocardiogram, measures the electrical activity of your heart. And it turns out the precise electrical signature of your heartbeat, the full shape of that wave as your heart beats, is as unique as a fingerprint. And maybe the most personal, the ultimate internal key, is your brainwave pattern. An EEG signal, which is just your brain's electrical activity, could be used for authentication. And because you can tie it to a specific mental task, like, say, thinking of your favorite song, it's unbelievably confidential and pretty much impossible for anyone else to replicate. Okay, I know, that was a lot to take in, but we can actually group all these new ideas into three pretty simple categories. First, you've got biometrics based on how you move, like your walk. Second, there are the ones based on what's under your skin, like your veins and heat signatures. And third, you have the ones based on your body's unique signals, like your heartbeat and your brain waves. Now let's zoom in and do a little deep dive on one of the most powerful and honestly fascinating biometrics out there, the human iris. It's just a perfect example of how a really complex biological feature gets turned into a highly secure digital key. So have you ever wondered why iris scanners use that little red light? Well, this slide shows you exactly why. In normal, visible light, what you mostly see is the color of the eye. But when you look at it with near-infrared light, that color, the pigmentation, basically becomes transparent. And that's what reveals the incredibly complex texture of the iris muscle underneath. That texture, that's the real key. So how does that texture become a code? Well, the pioneering algorithm for this, called iris code, follows these 4 steps. First, it finds the iris in the picture. Simple enough. Then, it digitally scrubs out anything that's blocking the view, like your eyelashes. And then, this part is really clever. It uses what's called a rubber sheet model to mathematically correct for your pupil changing size. And finally, it analyzes that unique pattern and converts it all into a 2048-bit digital string of ones and zeros. And what does all that complex work get you? It gets you this number. The chance of 2 different irises producing the exact same iris code is less than 1 in 100 billion. I mean, that is an astonishingly tiny chance of a false match, which is exactly why it's considered one of the most accurate biometric technologies on the planet. But, technology this powerful doesn't just exist on its own in a lab. As we unlock the ability to read this incredibly personal data, a whole parallel world of rules and rights has had to emerge to figure out how to govern it. So here's the crucial point. We have to establish what this data legally is. Under GDPR, which is Europe's big data protection law, biometric data is defined just like this. See, it's not just a picture or a number, it's personal data that comes from a specific technical process. And that's what gives it special legal protection. And because it's a special category of data, the standard for getting permission is incredibly high. It requires what's called explicit consent. And that means a company can't just bury it in the terms and conditions that nobody reads. You, the user, have to know exactly what you're agreeing to and then do something clear, like checking a box to say yes. Now, this whole framework gives you, the data subject, a ton of power. You have the right to be told exactly how your biometric data is being used. You have the right to see the data they have on you, to fix it if it's wrong, and, most critically, you have the right to have it deleted, the right to be forgotten. So let's circle back for a second to that EEG, the brainwave authentication. It's the perfect example of where things are heading. It has so much promise for security, but it also represents the ultimate in personal, private data. I mean, how do you even begin to regulate something that intimate? Well, this is the legal backstop. The law basically says that no matter how advanced the tech gets, the fundamental rules stay the same. Organizations must have a legal reason to process the data in the first place, and they absolutely must protect it with serious security. The burden of proof is on them, not on you. So, where does all of this leave us? We've seen some absolutely incredible technology, and we've also seen the really robust rules that are trying to keep up with it. And all of this leads us to the fundamental tension at the very heart of our biometric future. If there's one thing to take away, it's this. The better our technology gets at seeing and understanding our unique biology, the more critical those legal and ethical rules that protect our privacy become. The innovation and the regulation, they have to evolve hand in hand. And that, of course, leaves us with the final, big question. All these technologies, they offer us a future of seamless, invisible, effortless security, but they do it by reading the very fabric of who we are. So how do we draw the line? How do we balance all the convenience of these invisible keys with our fundamental right to privacy? That is the challenge ahead.